guys, my name is Craig and welcome to Peri Solutions. In today's video, we are going to talk about the operations of complex numbers, and this is to do with addition, subtraction, multiplication and division of complex numbers. But before we start, please make sure that if you're new to my channel, you hit the subscribe button and turn on the notification bell so that you don't miss out on any new videos. Okay, so to start off, right, we're going to start off by looking at addition of complex numbers. So let's say basically we've got two complex numbers. We've got C1, which is A plus BI, and C2, which is C plus DI. Right. So for addition of complex numbers, C1 plus C2, when adding complex numbers, we add the real parts separately, then we add the imaginary parts on their own. So A plus BI plus C plus DI. Right, adding the real parts, we're saying A plus C, right, then plus adding the imaginary parts, B plus D, I, like this. So this is for addition. Then for subtraction, C1 minus C2, right? So we subtract the real parts on their own, then the imaginary parts separately as well. So we're saying for A plus BI, minus C plus DI, right? We've got A minus C, then plus B minus DI, right? This is for subtraction. And then for multiplication, C1, C2, right? The normal rules of algebra, they do apply, right? So we just apply A plus BI times C plus DI. Then of course we have to simplify I squared, right? But since we know that I squared is equal to minus 1, so we have to simplify I squared at the end. And then we've got division, C1 over C2, right? A plus BI over C plus BI. Right, now for division, when dividing complex numbers, we multiply both the numerator and the denominator by the complex conjugate of the denominator. So we're going to say times C minus DI over C minus DI. Then we simply multiply to say A plus BI times C minus DI over, this is difference of two squares, so this is just C squared, and since this is minus D squared I squared, that becomes plus D squared. So this is how we carry out operations of complex numbers. So now I'd like to attempt those questions that require us to carry out the operations of addition, subtraction, and multiplication and division. Okay, so for number 1, A, we're told to simplify. This is addition. So we said for 1A, we simply add the real part. So 2 plus 3, we get a 5. And then plus the imaginary part, I plus 5I, we get 6I. So this is the solution for part A. Then for part B, we're saying 6 minus 3, we get a 3. Then we're saying minus 5I plus 8I, we get a plus 3I. So this is for the second part. Then for part 3, this is now subtraction. So 7 minus minus 2, the 7 plus 2, which gives us a 9. And minus I minus 5I, we get a minus 6I. Right, then for part D, that's also subtraction. Minus 1 minus minus 3, that's minus 1 plus 3, which gives us a 2. And then minus 2I minus minus 8I, that's minus 2I plus 8I, which gives us a plus 6I. Right, and then moving on to part E, if we first simplify this, we get a 12 minus 18I in brackets, right? And then of course plus, if we simplify, is if we decide to actually add, right? So plus minus 9 minus 15I, like this, such that we've got 12 plus minus 9, which is 12 minus 9 to give us a 3. And then we've got minus 18I minus 15I, which will give us minus 33I. Like this. So I suppose that should do it. Yes. This should be for part E. And then for part F, we're saying if we simplify the brackets first, we've got 4 plus 16i, right, minus 6 plus 21i, right? Then we've got 4 minus 6, which is minus 2, and then we've got 16i minus 21i, which is minus 5i. So this is the result that we get for part F. Pretty straightforward. Okay, so now moving on to number 2, we're asked to express in the form x plus iy, where x and y are real. This is multiplication. So this is now 2a. So for number 2a, we've got 3 minus 4i multiplied by minus I plus 2i. Minus 1 plus 2i. So 3 times minus 1, we get a minus 3. 3 times 2i, we get a plus 6i. Then minus 4i times minus 1, we get a plus 4i. Then minus 4i times 2i, we get a minus 8i squared. So simplifying, this will be minus 3, this we get 10i, and then I squared is minus 1. So minus 1 times minus 8, that's a plus 8. Minus 3 plus 8, we get a 5 plus 10i. So this is how we simplify 2a. Then simplifying 2b, for 2b, we need to carry out the division of 2 root 3i over 2 plus root 3i. We say for division, we multiply both the numerator and the denominator by the complex conjugate of the denominator. So we're saying multiplied by 2 minus 3 minus root 3i over 2 minus root 3i, right? And of course, if we say 2 times 2, we get a 4. 2 times minus root 3i, we get minus 2 root 3i. Then 2 times minus root 3i, we get a minus 2 root 3i. And then minus root 3i times minus root 3i, we get a plus 3i squared. Then this is over, this being difference of 2 squares, 2 times 2 we get a 4, and then I squared root 3i times root 3i, we get a root 3i times minus root 3i, we get a minus 3, so in actual fact, we get minus 3i squared. And if you further simplify this, this is 4 minus 3, because I squared is minus 1, which gives us a 1, and then minus 4 root 3i over, this we know is minus 1. So minus 3 minus 1, that's a plus 3. 4 plus 3 gives us a 7. So this is the result that we get for part B. Then now we shall move on to look at number 3. So allow me to erase this. Okay, so now looking at number 3. Number 3 says the complex conjugate z is given by root 2 minus I. Express z squared in the form x plus iy, where x and y are real. So we're saying root 2 minus I times root 2 minus I, right? And root 2 times root 2, we know we get a 2. Root 2 times minus I, that's minus root 2i. Minus I times root 2, that's minus root 2i. Minus I times minus I, that's a plus I squared. Right, and then we know I squared is minus 1, so 2 minus 1, we get a 1. Then this will be minus 2 root 2i. So this is the result that we get for 3a. Then for 3b, first part, 3b says the complex conjugate of z is denoted by z. Then the star at the top there. Express the following in the form x plus iy, where x and y are real. So we've got z plus its complex conjugate. So we're saying root 2 minus I plus root 2 plus I. Root 2 plus root 2, we get 2 root 2. Right, and then minus I plus I, that gives us a 0. So we just get 2 root 2, right? And then moving on to what is it code. Now moving on to part 2. Part 2, we are supposed to simplify 2 times z, right? 2 times z minus z, right? So we're saying 2 in square brackets here. Then z, we've got root 2 minus I minus root 2 plus I. It's complex conjugate. So if we carry out the subtraction first, we're saying root 2 minus root 2, we get a 0. In minus I minus plus I, this minus I minus I, we get a minus 2I. So 2 times minus 2I, we get a minus 4I. So this is for part 2. And for part 3, we need to simplify 5 times z times its complex conjugate. So we're saying 5 times its complex conjugate. We're saying root 2 minus I times root 2 plus I. This will be 5 multiplied by root 2 times root 2, we get a 2. And then root 2 times I, we get a plus root 2I. And then now this is difference of 2 squares. So we're only worried about the first term, which is root 2 times root 2 to get a 2. And the last term, minus I times I, we get a minus I squared, which is plus 1. Right, so 5 times 3 there, we get a 15. Okay, so this is how we simplify part 3. And now moving on to the last part, which is part 4. We're saying z, which is root 2 minus I over I times root 2 plus I. This is root 2 minus I over root 2I. I times I, that's I squared, which is minus 1. So we are multiplying this by the complex conjugate of the denominator, which is root 2I plus 1 over root 2I plus 1. And then this would simplify to root 2 times root 2I, we get 2I, right, 2I, and then root 2 times 1, we get a root 2, right, and then minus I times root 2I, we get minus root 2I squared. But we know I squared is simply minus 1, so minus root 2 minus 1, we get a plus root 2. And then minus I times 1, that's minus I, and this is over, this being difference of 2 squares, we're only concerned about the first term and the last term. So root 2I times root 2I, that will give us 2I squared, which is minus 2, because we know I squared is equal to minus 1. Then minus 1 times 1, we know that's minus 1. So simplifying this, root 2 times plus root 2, you know this is, you know, rather write it here. You know this is 2 root 2. 2I minus I, that's plus I, over minus 2 minus 1, that's minus 3. So this is the result that we get for part 4. Okay, so this was looking at the arithmetic operations of complex numbers, which is addition, subtraction, multiplication, and division. So please feel free to leave a comment, drop a like, and don't forget to subscribe. Thank you.